Alright guys, this video is going to be speed versus velocity. And it is required in this video that you know the difference between distance and displacement. So if you don't know the difference, just watch my previous video. I go through it in a few examples. It'll only take a couple minutes, and then come back to this video so you can understand speed versus velocity, because that's what this video is about. Now notice how I put speed and distance side by side, and I put velocity and displacement side by side. That is because speed and distance are, if we look at vectors, vectors have a magnitude and a direction. So this is going to the east, right? 6 meters east. It says that in the problem. 6 meters to the east. That is a magnitude of 6, and the direction is east. Now, if you remember from the last video, when we were doing distance, the direction did not matter. You just added everything up. It's the same thing with speed. Speed does not have a directionality, only a magnitude. Velocity considers the magnitude and the direction. Displacement is the same thing. If you guys remember, if you go 6 meters to the east and then 8 meters to the west, you don't add them all up. You find the distance between them, right? Because the directionality matters on top of the magnitude. So that is the main consensus of velocity versus speed, but we're going to go through this example to make sure it makes sense in your head. So Peter Parker walks 6 meters to the east, right? So we just drew that, and east is always to the right. If you don't know your directions, watch the last video. Take a rest, okay? So we're sitting, we're chilling in this dot right here, and then we walk 8 meters to the west. 8 meters west, and west is left. All right, now it took him 30 seconds to complete these motions. So the total time it took was 30 seconds, okay? And what is his average speed? Wow, that is a great question, Emmett. So speed is going to be equal to, remember, we were talking about speed is equal to, it's just magnitude, just like distance, right? So distance, total distance over the time it took to travel that distance. That's your speed. So what is his average speed? We'll find the total distance. It's 6 plus 8, right? We've solved that in the last video. So 14 meters over the 30 seconds. And that, right, is going to get our speed of 0.467 meters over seconds. So meters per second. Boom. That is our speed, everybody. 0.467 meters a second is our speed. Okay, now we're going to do this problem again, all over again, changing one thing. What is his average velocity? Wow. Challenging stuff, ain't it? Okay, cool. So now it's velocity. Velocity has magnitude and direction, just like, you're correct, displacement, not distance. So it's the exact same thing, right? T is equal to 30 seconds. When we go 6 meters to the east, and then we go 8 meters to the west, then our displacement here is negative 2 meters. Wowza. When we're doing the math, we want to do negative 2 meters, because in math, you cannot say west and just plug it in and get another value. So we're using negative here. If you didn't know that, watch the last video. That's the last time I'm going to say that. So, negative 2 meters. All right. that is our value that we just got for our displacement. And velocity, my friend, is going to be displacement, the total displacement over time. So it's basically the same thing as speed, except now, instead of just the magnitude, we're also incorporating the direction. That's awesome. Okay, so velocity is equal to -2 meters of displacement over the 30 seconds, which is basically just equal to -1/15, which is going to be -0.067. Oh, can I fit that in? Meters a second. And that is our velocity right there. So our velocity can be positive or negative. Our displacement can be positive or negative. But our distance and speed will only ever be positive. So, because it's just magnitude, where velocity and displacement involve direction. So you got to really ingrain that into your mind. And that's it. That is this video. Now you guys know the difference between speed and velocity, hopefully. If not, rewatch the video or watch a different video. I don't know what to tell you, but yeah, that's about as easy as it gets. So